Hey guys, welcome to AA5b-4. In this unit, this section, this is the last section of Unit 5, so we will be reviewing and then testing. We're going to be solving systems of inequalities by graphing. A lot of you are going to be familiar with a lot of these concepts, but we're going to be pushing them forward into the different types of graphs that we've been doing since the beginning of the year and how to deal with those. So I did want to remind everybody of some of those types of graphs and what their equations look like. The parabola is your a times x minus h squared plus k. So that's that form right there with the vertex of hk. Absolute value is y equals a times the absolute value of x minus h plus k. That makes the V shape, and the vertex as well. That's your hk. The important thing to remember with both of these, both of these have x minus h for their h value, and so because of the minus, when h is a positive, it moves it to the left, and when h is a negative, moves it to the right. So it's important to note that people often forget it and move it the wrong direction, left or right. Circle graph we've done just a little bit with. This one is x, and it's not a function, so it's going to work a little differently. X minus h plus y minus k squared, sorry, both of those are squared, equals the radius squared. So in this case, the hk is the center of our circle. So we've got our hk right there, and then r is the radius, so the distance from the center out to any point on the edge. That one's not a function. In terms of shading and how we deal with it, it's going to be a little bit different, but we'll get there in a bit. And then I just wanted to remind everybody of the slope-intercept form of a line. So mx plus b, wow, it would help if I actually wrote x. There we go, mx plus b. M is your slope, and b is your y-intercept. And so that's just, start at your y-intercept and go up and over according to your slope, in just a straight line. All right, so moving forward, when you're graphing an inequality, best thing you can do is use a pencil. There are so many different ways to screw this up, and it gets really messy really fast if you are doing this all in pen. So you're going to graph the equation. You're going to graph it just like you would the equation, but there's a couple of important differences. One of them is the type of line you use. So if you have less than or greater than without the underneath that or equal to line, then you're going to use a dashed line. And what that indicates is that that this is that all the values on the line are not included in our solution set, whereas a solid line, the or equal to, all the solutions on that line are included in the solution set. Once you have that graphed, and that's another place where it's really good to have a pencil, because if you accidentally do a solid line, you can pretty easily just erase little marks in between and make it a dashed line. So for shading, if it says y is less than, then you're going to shade below. If it says y is greater than, you're going to shade above. One thing here, and this works with both the circle and the lines or any other type of equations. I'm going to scoop this up just a bit. If I am graphing something, say I graph a line. Oh, that one's not that hard. So let's look at something like this. It's a little bit harder to see. So if I've got something like y is greater than, let's call that 2x plus 1. For some people, it can be rather difficult to determine if this side of the line is above or if this side of the line is above, because according to this, I'm going to shade above the line because y is greater than. So one of the things that you can do is simply pick a test point. So I could pick the point, 2, -1. And I can put the x and the y into my inequalities. So y is greater than 2, and then I've got 2 from my point, plus 1 from my equation. Oh, sorry. I just realized I didn't write the -1 for y. So I'm basically just taking that and putting it there, and that, and putting it in for x. And then I just evaluate. So -1 is greater than 4 plus 1. So -1 is greater than 5. And it's not true that -1 is greater than 5. -1 is actually less than 5. So what I can do is, because this point is down here, and I know it doesn't work, then nothing over here is going to work. So then I know that I'm going to shade everything above the line as my solution region. So if you have a hard time recognizing what below and what above is, just pick a point, and if it works, that's where you shade. If it doesn't work, then you shade the other place. So different things work for different people. Just pick which works best for you. In a circle, it's a little bit different. It's an inside-outside situation. So for the circle, if it's less than, and this should be r squared, then you're going to shade inside. If it's greater than, you're going to shade outside. And once again, depending on which side the r squared is, because some of them have the r squared over here, which kind of flips the sign, which can make the entire idea a little bit confusing. Let's say you have a circle with a center of -3, 2. So that's our HK. What you're going to do is you can take that -3 and 2 and plug it into, so okay, let me make up an inequality real quick, hang on. So that would be x plus 3 squared plus y minus 2 squared, and let's say that is greater than 9. If I use the test point of the center, and I plug that in, so I've got x minus 3 plus y minus, sorry, just kidding. Ignore that last little part. I'm going to try that again. So I'm taking, taking my -3, putting in for x, and my 2, putting it in for y. So let's try that again. So I've got -3 plus 3 and 2 minus 2 squared. All of this on this side, whenever I put the center in, is always going to give me 0. So since I tested the center point, if it's true and the center point works, then I'm going to shade everything inside. This says that 0 is greater than 9, which is definitely not true. And in that case, I would shade everything around the outside of the circle because the center didn't work. So in terms of the inside and outside, that's your call how you decide to do that. If you want to memorize this little bit or keep it in your notes, or if you just want to use a test point. And a test point is not a bad idea anyway, because I am going to require it on the test that you pick a test point in your solution region. What we're looking for when we have a system of inequalities is the overlap, the part where it's shaded in both. So if I have, if I put a line back on here that I had shaded, I'll make that a different color, that I had shaded above So everything up here. Then the solution region I'm looking at is the place where it's shaded for both of them. And we'll do these examples on the next page, but just to give you an overview of what we're talking about. So for examples, this first one, this is an absolute value. I'm going to change the color here in a moment because that's really difficult to see. My HK for this is 3, and this would be like I had a K of plus 0. So HK here is 3, 0. So I'm going to plot the point 3, 0. And then I'm going to make my absolute value graph. And I'm going to note that this is greater than, and it does not have the or equal to line, so I need to take out some parts there to make it a dashed line. And then because it's also greater than, I'm going to shade above the line, so everything above it. Another teacher here likes to use the idea of if the rain was falling, where would it hit? So if you've got rain coming down from the top, it's hitting up here. It's not going to come down here. It'll be blocked by this part. So next one is a parabola or a quadratic. Its HK is 3, negative 2. If you're having trouble graphing these, by the way, go back to AA5b-4 is where you're going to find all the parent graph stuff and how to do that and the transformations. So I'm going to go ahead and graph that point, 3, negative 2. I'm going to go out 1 and up 1 in both directions. And then this one's going to be a solid line because of that or equal to line. And this is also greater than. So once again, I'm going to shade above. And my solution region is the parts here where it's shaded in both green and red. So everything up here can be a possible solution. And you can't really, it's a pretty difficult task to think about writing that in terms of x is greater than or y is greater than, because you're looking at different values for y depending on what x is. And our last part is to test a solution. So I'm going to pick a point that's in that area, and I'm going to go ahead and pick the point 1, 7. And I'm going to put that in for x and y in both inequalities and make sure it works. So the first one, I'm going to have 7 is greater than the absolute value of 1 minus 3. That's not a parentheses, that's the absolute value. So 7 is greater than 1 minus 3 is negative 2. The absolute value of negative 2 is 2. And it is true that 7 is greater than 2. So we're good to go on that one. The other one, I'm going to test in that parabola. So I've got y is greater than or equal to, except I don't want y, I want 7. Just on top of my game today. 7 is greater than or equal to 1 minus 3 squared minus 2. So 7 is greater than negative 2 squared minus 2. 7 is greater than or equal to 4 minus 2. And 7 is greater than or equal to 2. So this amount of steps is not super duper necessary on a test, but do show it being plugged in and do show your final result. And this one, by the way, also true that 7 is greater than or equal to 2. So this is our solution region. Next up, we've got a circle and a line. So circle over here has a center of -2, 3. So the thing you want to be careful with the circle that's not the same with any of our other types of equations, at least not the ones that we've done, is that they're both x minus and y minus. And so if this is x plus 2, then that means we had a -2 in for our h. So it'd be x minus a -2 to get x plus 2. With y minus k, it's the only one that switches k as well. So y minus 3, 3 is in place of our k. So our hk is -2, 3. If our number over here is 9, then 9 equals our r squared. So radius equals just a positive 3. We're not going to worry about the negative value because radiuses are positive. So what we're going to do then is we're going to go to -2, 3 and make a point. And we're going to go up 3, left 3, down 3, and right 3. This is just less than. It's no or equal to line underneath it. So we're going to make a dashed line and do the best we can to make a circle. That can be very challenging. And because this is less than, I am going to go ahead and shade inside. And that's using our rule from the notes. The other thing we can do is test a point, but we'll test a point once we've shaded for both. Then over here, not the right one. This is just a line, or y equals mx plus b. So this is a line with a slope of -2 and a y-intercept of -3, or 0, -3. So we're going to start at 0, -3. We're going to go down 2 and right 2, or right 1, I'm sorry. And then we're going to backfill it in the other direction by going back 1 and up 2. And this is also going to be a dashed line. And this is greater than, so I'm going to shade above it. And quite conveniently, our center falls in that region that's shaded by both. So I'm going to test the point -2, whoops. I'm going to test the point -2, 3. It's going to be pretty easy to do in my circle because I'm going to put -2 plus 2 squared plus 3 minus 3 squared is less than 9. I end up with, over here, again, always, whenever you put the center in, you're going to get 0. 0 is less than 9. That is true. So that tells me I've shaded the circle correctly at least. And then I'm going to put in 3 for y. It's greater than -2 times -2, oops, minus 3. So 3 is greater than 4 minus 3. 4 minus 3 is 1, and it is true that 3 is greater than 1. So because that worked in both inequalities, that tells us that this shaded region, and you might want to wait to like shade it darker after you've already tested your points. It can keep you from making very messy mistakes. So anything in this region, not including any of our lines because they're all dashed, will be a solution to both of these inequalities. So that is it for this one. Just be aware on your test next class you will have 1 page of notes available. I would suggest pulling out all the notes that we've taken from these from the Unit 5 stuff and kind of paraphrasing or rewriting them. Don't just rely on examples because people really don't do that well when they do that. That's it. Have a good day.